This is the second video of work energy theorem. In this video, I have solved from question number 126 to 130 of irodov. So some basics of spring constants are given, some basics of springs are given. So just go through the video and enjoy the lecture.
In this question, what is given is that there is a particle moving in a circular orbit. Okay, this particle is moving in a circular orbit. Okay, and the normal acceleration or the centripetal acceleration is being given by omega n is equals to at square. So instead of using omega n, I'll use an or normal acceleration because it is much familiar. But a is equals to a constant. So normal acceleration or centripetal acceleration is equals to at square. Okay, now see. Suppose the particle was moving with velocity v. Okay, if you look at this normal acceleration or centripetal acceleration, if you notice out here, the centripetal acceleration is increasing with respect to time. Okay, so to keep the particle in a circular orbit, the velocity also must increase with respect to time. Why? Because if the velocity remains constant, what will happen is this centripetal acceleration will pull the particle towards itself and the particle will deviate slowly towards the center of the circle. Okay, so in order for this particle to continue in a circular orbit, the velocity also must increase, okay, to compensate the increase in centripetal acceleration. Okay, this much is understood. Now what is centripetal acceleration or normal acceleration given by? V square by r. So at any time instant t, say the normal acceleration is equals to v square by r, which is given in the question as at square. From this relation, can I deduce v square is equals to rat square, or v is equals to under root of ra into t, which is outside the square root. Okay, now if you notice out here, I found out the function of velocity with respect to time. That means how the velocity increases as time increases or as time goes on. Okay, so can I put ds by dt, or rate of change of distance, which is nothing but velocity. This velocity can be written as ds by dt, no, or the amount of distance traveled in a circular orbit, which is equals to how much? How much is the velocity? R a into t. Okay, so if I integrate this, ds is equals to ra into t dot dt. Okay, or s is equals to under root of ra t square by 2 plus some constant. Okay, the boundary condition is at t is equals to 0. At t is equals to 0, s is equals to 0. Why? Because whenever you are measuring distance, you always assume at time t is equals to 0. That means when the clock started, the distance covered is equals to 0, because we will measure distance by assigning the initial distance to be 0, no? So at t is equals to 0, s is equals to 0. If you put both this equation out here, the value of constant will come out as 0. Okay, now we had the velocity, we had the distance. Now I need to find out the tangential acceleration, because velocity is also increasing as it moves along the circular orbit, no? So there is a tangential acceleration, and tangential acceleration is nothing but dv by dt. Okay, what is v? V is nothing but under root of rat. So if you differentiate this term with respect to t, what will you get? You will get under root of ra. Under root of ra. So tangential acceleration is under root of ra. So notice three things. First, I found what was the given in the question was normal acceleration. For normal acceleration, I found out the tangential velocity. From tangential velocity, I found out the distance covered as a function of time. Okay, and from velocity, I also found out the tangential acceleration. Okay, now in the question, what is being asked is the power developed by forces acting on the particle, and the mean value of this power averaged over the first t seconds from the beginning of motion. Okay, so two things are being asked. First is the instantaneous power, and second is the average power. Okay, the instantaneous power and the average power. Okay, one thing you must notice out here, in circular motion, or one thing you must know out here, in circular motion, okay, only tangential force does some work. Okay, note, in circular motion, in circular motion, work is only done by, work is only done by tangential force, tangential force, not centripetal force. Okay, therefore power is only developed by tangential force. Power is only developed by tangential force, tangential force. Acha, why not centripetal force? Because for centripetal force, the displacement or the instantaneous displacement at every point in the circle, the angle between angle between centripetal force and instantaneous displacement is always 90°. That's why centripetal force does not do any work in circular motion. Understood? So we need to find out instantaneous power. Okay, what is instantaneous power? Instantaneous power is nothing but dot product of force and velocity. So first one is, or first part is power or instantaneous power. Instantaneous power is nothing but dot product of force and velocity. Okay, what is force? Mass into tangential acceleration. Because we are finding out tangential force, we need to find out mass into tangential acceleration. What is tangential acceleration? Under root of RA. Tangential acceleration is under root of RA. What is tangential velocity out here? Tangential velocity is nothing but under root of RA t. Tangential velocity is nothing but under root of RA into t, which is outside. If you multiply this both, we'll get m into RA is nothing but RA into t. So this is nothing but the instantaneous powered by tangential force, m RA t. Now the second part of the question is, find the mean value of this power, or average power. Instantaneous power is force dot velocity. What is average power? Average power, okay, is nothing but total work divided by total time. Whenever average comes out, total divided by total. What is the total work? Suppose from t is equals to 0 to t is equals to some time, the total work done is force into displacement. Or what is the force? What is tangential force? It is nothing but m into under root of RA. So tangential force is nothing but m into RA. Sorry, m into under root RA. What is total displacement during t is equals to 0 to t is equals to time t? Okay, total displacement is given by this equation. S is equals to under root of RA t square by 2. Okay, so under root of RA t square by 2, and what divided by total time. What is total time? For the first t seconds. Okay, average power is nothing but total work divided by total time. What is total work? Force into displacement divided by total time. Okay, not displacement. Out here I'm using distance. Why? Because at every point, okay, see out here little bit of displacement, out here tangential force. Out here the direction of tangential force will always be in the direction of tangential displacement, no? So even if the direction of displacement is changing, the direction of tangential force is also changing along the direction of displacement, no? So if you consider distance out here, it won't be incorrect in circular motion. Understood? So out here t and t would get cancelled, t and t square would get cancelled. So our average power is nothing but m RA t by 2. Sorry, instantaneous power is m RA t, average power is m RA t by 2. In this question, what the question says is that there is a ground. On top of this ground, there is a block of mass m, okay, which has the initial velocity of v naught. The coefficient of friction between the ground and the block is k. So what will happen? The initial velocity is v naught and friction force is acting on this block in opposite direction. So friction force will try to stop on the block, try to stop the block. The first part of the question is asking the mean power developed by friction force during the whole time of motion. Okay, that means what? The friction force will act in opposite direction till this entire body stops. Okay, so what is the value of friction force? The value of friction force is nothing but mu mg. Friction force is equals to mu mg or mu n, and n out here is equals to mg. Okay. Achha. What is mean power? Mean power is nothing but average power, and average power is nothing but total work done. Total work done divided by total time. Total time. Okay. So how do I find out the total work done? Okay. I have found out the friction force. Total work is nothing but dot product of force into displacement. Okay. Work done is nothing but dot product of force and displacement. I know the value of friction force. How do I find out the displacement? Okay. See, if I know the force out here, do I know the acceleration? Acceleration or acceleration in opposite direction is nothing but force divided by mass, or friction force divided by mass. Why? Because force is equals to mass into acceleration, or mu mg by m. Okay, or is equals to mu g. I did nothing out here. Is, see, we know that force is equals to mass into acceleration. Okay, out here force is what? The friction force, or mu mg. Okay, or mu mg is equals to mass into acceleration. Out here mass and mass gets cut. Acceleration is equals to mu mg. So out here we also know that acceleration is equals to mu g, or acceleration is equals to mu g. Okay, in opposite direction. Fair and fine. Can I apply v square is equals to u square plus 2as? V square is equals to u square plus 2s. And why can I apply this formula? Because out here the value of acceleration is constant, so I can simply apply these three, one of the three formula for kinematics where acceleration was constant. So what is the final velocity? The final velocity is 0. See, the ball started with initial velocity v naught. After some time it came to stop. The friction force will stop the block, no? So the final velocity is 0. The initial velocity is v naught. Acceleration is nothing but minus ug. Why minus ug? Because if this side is positive v naught, this side should be minus mu g. Assign the coordinate system: plus, minus, plus, minus, and we need to find out the value of s. So out here 0 is equals to v naught square minus 2 mu g s, or s is equals to v naught square by 2 mu g. Okay, so I have the value of force. Okay, the value of force, the value of friction force, the value of displacement, the value of displacement. What I need to find out is the value of time, or total time. Okay, how do I find out total time? What is the time taken to stop out here? Okay, this is nothing but distance is. What is the time taken? See, in this entire journey, if the acceleration is constant, can I apply the three laws of kinematics where acceleration was equals to constant? V is equals to u plus at, s is equals to u2 plus half at square, and x is equals to v square is equals to u square plus 2s. So these are the three laws of kinematics you can apply where acceleration is constant. The final velocity out here is 0. I'm simply applying V is equals to U plus AT to find out the total time. U is equals to V naught, acceleration out here is equals to minus mu G. So time out here would be equals to nothing but T is equals to V naught by mu G. So I found out the time also. Now simply substitute out here. Average power is equals to force. What is force? Mu mg. Okay, displacement. Force is mu mg. Displacement is v naught square by 2 mu g. V naught square by 2 mu g divided by total time. What is total time? V naught by mu g. V naught by mu g. So out here g and g would get cancelled. Mu and mu would get cancelled. Okay. And anything left? M v naught square by 2 v naught and mu g would travel upward into mu g. V naught and v naught square would get cancelled, or m v naught mu g by 2. This is the average power developed by friction force. Achha, one more thing. Okay. See out here. One thing you have to note out here is the friction force. The displacement acts opposite to the direction of friction force. So out here total work would be negative. So out here total work is negative. Out here the power is also negative. Why? Because displacement is opposite to the direction of friction force. Yeah. One more way of solving this is using change in kinetic energy is equals to total work done by all the forces. See, out here only friction force is doing the work, no? So total work is nothing but final kinetic energy minus of initial kinetic energy. Okay, final kinetic energy is 0, initial kinetic energy is half mv naught square. So you don't have to do this total force, displacement and all these things. Understood? You can simply apply change in kinetic energy is equals to total work. Okay, so that is one more method. Now the second part of the question is asking the maximum instantaneous power. Instantaneous power is nothing but dot product of force and velocity, F dot V. The maximum instantaneous power developed by the friction force if the friction coefficient varies as K is equals to AX. See, out here the coefficient of friction was, I wrote K but used mu. Okay, I'll use mu as friction coefficient. Okay, in this, even though irodov uses K, I'll use mu. Okay, it's irritating. Okay, so the second part of the question is asking this mu, okay, will vary as the block travels forward. Okay, that means in the first part of the question, what was happening? This mu was staying constant as the block moves forward. It was fairly constant. Okay, and we got the total work, total time. But in the second part of the question, see, as the body goes forward, the ground become coarse and coarse. Okay, and somehow the coefficient of friction increases as the body goes forward. Okay, so if the coefficient of friction increases, the friction force also increases. The question is asking find the maximum instantaneous power if the coefficient of friction force varies as mu is equals to ax. See, out here there is a ground and there is a block of mass m. It is projected with velocity v naught. In the second part of the question, however, the mu, okay, the coefficient of friction is variable, or alpha x. That means as the block move forward or as you go farther in the ground become coarse and coarse. Okay, so the coefficient of friction keeps on increasing, and this friction force or this coefficient of friction will be used in friction force. Okay, okay. The question is asking find the maximum instantaneous power. Maximum instantaneous power. What is instantaneous power? Instantaneous power is nothing but dot product of force and velocity. Okay, if you realize out here what is the value of friction force, the value of friction force is nothing but mu mg, when mu given in the question is alpha x. So the value of friction force becomes alpha x mg. Now if you notice out here, see our x is starting from out here. Okay, our coordinate x is starting at the point of motion. So at x is equals to 0, friction force is equals to 0, but velocity is equals to v naught. And as the block moves forward, the coefficient of friction will increase. Okay, if you notice one thing out here, instantaneous power is equals to force into velocity. So initially it will have a minimum value of friction force and a maximum value of velocity. After some time, what will happen? The friction force will increase, which will decelerate the mass m, and finally what will happen? The mass m will come to stop. Okay, and finally we'll have the maximum value of friction force and minimum value of velocity. Okay, what I'm trying to say is that initially we'll have maximum value of velocity and minimum value of friction force. Okay, so power will be around 0. At the end of the motion, we'll have maximum value of friction force and minimum value of velocity. Okay, so out here also power will be around 0. So somewhere between the start of the motion and the end of the motion, the power will be maximum, no? And I have to find out the maximum value of power. Okay, so in order to find out the power, let's say I have to find out the velocity. Now how do I find out the velocity? First I need to find out the acceleration. And how do I find out the acceleration? Force is equals to mass into acceleration. Okay, where force is nothing but the friction force acting on the block, or alpha x mg is equals to mass into acceleration. M and m gets cancelled, or alpha gx is equals to acceleration. Achha. Out here acceleration is acting in the opposite direction to velocity, which is equals to alpha gx. Okay, see. So if the acceleration is acting opposite to the direction of velocity, you can easily mention that this is deceleration. Okay, deceleration is given by negative. Okay, can I use v dv by dx? Or I'm doing my calculation out here. Can I use v dv by dx? See out here. Acceleration was equals to alpha gx, or deceleration is equals to minus of alpha gx. Okay, because minus came because velocity and acceleration are in opposite direction. Okay, you have to use the coordinate system out here. Now can I use v dv by dx is equals to minus alpha gx, because acceleration can also be written as v dv by dx. Achha, why didn't I use v square is equals to u square plus 2s, or v is equals to u plus at? Because out here the value of acceleration was constant. Okay, in the previous problem the value of acceleration was constant. However, out here the value of acceleration is variable out here. Okay, is not constant out here. So I can easily say v dv is equals to minus alpha gx into dx, or v square by 2 is equals to minus alpha g x square by 2 plus some constant. In order to find out the constant, we need to put out boundary condition. At x is equals to 0, that means at initial point at x is equals to 0, v is equals to v naught, no? V is equals to v naught. So if you put x is equals to 0 and v is equals to v naught, the value of constant becomes v naught square by 2. So I can easily say that v square by 2, okay, minus v naught square by 2 is equals to minus alpha g x square by 2. Okay, out here 2 and 2 will get cancelled, or v square is equal minus v naught square is equals to minus alpha g x square, or v square is equals to v naught square minus alpha a g x square, or if I remove square root from this v, I'll get v is equals to under root of v naught square minus alpha gx square. So the value of velocity, okay, is obtained in parameter of space, or velocity is obtained as a function of space or distance. Okay, I already got the velocity as a function of distance. Okay, if I simply apply power is equals to force, what is the value of force? Alpha x mg. Alpha x mg. What is the value of velocity? The value of velocity is nothing but under root of v naught square minus, or under root of v naught square minus alpha g x square. Okay, now I have to find out the maximum value of this power. See, even at this equation of power, at x is equals to 0, okay, what will happen? At x equals to 0, power will be minimum, and at x equals to final time, what will happen? The power will be 0. Okay, so at both the starting and ending, the power is equals to 0. Somewhere between the motion, the power will rise to a maximum value, and you have to find out that maximum value. And in physics, whenever maximum or minimum comes up, what do you have to do? You have to differentiate and make it equals to 0. So out here, power is given as a parameter of distance. So can I write at maximum power dp by dx is equals to 0? So I'll do that in the next page. Now I have to differentiate this dp by dx and make it equals to 0. Okay, so out here you are differentiating dp by dx, so remaining of the term are simply constant. So if I write p is equals to alpha mgx under root of v naught square minus alpha g x square, I simply written this equation as this equation alpha mgx, and the remaining portion are same as it is. So all I'm doing is substituting this complex term by simpler term. Let this be a, okay, let this be b, and let this be c, okay, or this be b and let this be c. Okay, so I can rewrite my power as ax under root of b minus cx square. Okay, now see, if I put it inside the bracket, or if I put ax inside the bracket, under root of a square x square into b minus cx square, okay, or p is equals to under root of a square b x square minus a square c x to the power 4. Okay, I can simply write this under root as to the power 1 by 2, to the power 1 by 2, to the power 1 by 2. Okay, now dp by dx, if I do dp by dx is equals to 0, or if I differentiate this entire term and make it equals to 0, what will happen? Half a square b x square minus a square c x to the power 4 to the power 1 by 2 minus 1. 1 by 2 minus 1 is nothing but minus 1 by 2, minus 1 by 2 into, now we differentiate inside the bracket, into 2x a square b minus 4x cube a square c should be equals to 0. Now for this entire term to be 0, okay, see, if you make this term 0, no, this entire term will be infinite. Why? Because minus 1 by 2 will go down, and anything divided by 0 is nothing but infinity. So the only option left is this term to be 0. So out here 2x a square b minus 4x cube a square c is equals to 0. I can send this entire term to the right hand side, or it will become 2 x a square b is equals to 4x cube a square c. A square would get cancelled. X and x cube would get cancelled to become x square. So let's a square, a square, x cube cancelled to become x square. Okay. 2 and 4 would get cancelled. 2 cancelled by 2. So out here 2 become 2 out here. Okay. So out here, if I rewrite this equation, b is equals to 2x square c, or x square is equals to b by 2c. Now what was the value of b? The value of b was v naught square. V naught square. What is the value of c? The value of c was alpha g. Alpha g. So x square is equals to v naught square by 2 alpha g. So the condition for maximum power is that x square is equals to, or x is equals to v naught by under root of 2 alpha g. What will happen? Power will have the maximum value. Okay. Or x is equals to v naught by under root of 2 alpha g. I simply square rooted both left hand side and right hand side. Now all you have to do is substitute this value of x in this equation. Okay. Or let's substitute the value of x square is equals to b by 2c in this equation. Or p max. P max is equals to a square b into x square. Okay. X square becomes b by 2c. B by 2c. Why? Because for maximum power, x square is equals to b by 2c. Okay. Minus a square c, x to the power 4 can be written as x square whole square, or x square whole square, or b by 2c whole square, or b by 2c whole square. Okay. So out here, if we just simplify this, power max is nothing but, see out here, b and b becomes b square, b and b becomes b square. Okay. Out here, this entire bracket, if opened, becomes b square by 4c square. So this entire bracket becomes b square by 4c square. Okay. Out here, c and c square would get cancelled. So c and c square got cancelled. Okay. So out here, a square b square by 2c minus a square b square by 4c. Our power max is equals to a square b square by 2c minus a square b square by 4c. Okay, so it is nothing but, if you take a square b square by c common, 1 by 2 minus 1 by 4, and 1 by 2 minus 1 by 4 is nothing but 1 by 4. Okay, so I can simply rewrite this entire equation as a square b square by 4c, or maximum power is equals to a square b square by 4c. A square b square by 4c. Now what was the value of a? Alpha mg, or alpha square m square g square. What is the value of b? The value of b was v naught square and b square. So v naught to the power 4. Okay. Divided by, what is the value of c? The value of c was alpha g by 4 alpha g. Okay. So out here, alpha and alpha square will get cancelled. G and g square would get cancelled. Okay. The remaining terms are, let's cancel alpha, alpha, g, g. The remaining terms are this. Now one more crucial step. I have forgotten this 1 by 2 out here, no? I have forgotten entirely about this 1 by 2. I didn't put this 1 by 2. See, to the power 1 by 2. To the power 1 by 2. I just solve for this part only, no? So this part will also contain to the power 1 by 2. And this part will also contain to the power 1 by 2. So if we square root this entire term, or P max is nothing but I'm square rooting this entire term. Okay, is under root of alpha, m square would become m, g would become under root g, v naught to the power 4 would become v naught square by under root of 4 is nothing but, or if I rearrange this, it is nothing but m v naught square under root of alpha g by 2. So this is the value of maximum power. This question is fairly simple. Okay, the axis is there and this axis is rotating with 5 radians per second. Or let's use variables out here instead of using the actual values, omega. Okay, and in this rotating axis there is a observer out here. Say a disk is out here, or a rod. Instead of disk, a rod is rotating with angular velocity omega. Okay, it can be anything, a rod, disk, it doesn't matter in this question. Okay, now a particle is kept at distance 30 centimeter from the axis of rotation. What will happen? This particle will experience centrifugal force. Okay, and due to the centrifugal force, from the perspective of this observer, the particle moved to 50 centimeter, or x2. Okay, the particle moved to x2. Okay, the question is asking what is the work done by centrifugal force. The answer is simple. First we have to find out centrifugal force. So out here at any point, centrifugal force is equals to m omega square x, where x is nothing but the distance from the axis. Work done, or elemental work done, is equals to force into elemental displacement. Okay, why did I put dx out here? Because as the particle moves outer, no, the value of x will change. Okay, that's why I have to integrate this entire thing, where force is equals to m omega square x, where x is the distance from the axis. Work done is equals to m omega square x dx. Okay, or total work done is equals to m omega square x square by 2. Acha. From where to where is the integration? You can either use direct integral or indirect integral. Both will have the same effect. Okay. So in order to save some time, I'm using direct integral. From x is equals to x1 to x2. So x1 to x2, or omega is equals to m omega square x2 square by 2 minus x1 square by 2. Okay, this is the total work done by centrifugal force. Out here, instead of using r1 and r2, I have used x1 and x2. You all understood this thing, so just read the question, figure it out.
Before solving this question, we'll learn some fundamentals about spring force. Okay, the first one is spring force. Spring force is nothing but whenever a spring is compressed or elongated, okay, the force is given by kx, where k is the spring constant and x is the elongation or compression of the spring. Next, we'll learn series and parallel addition of springs. Okay. Now the first one is series addition. Whenever two springs are added in series and it is replaced by an equivalent spring for the ease of calculation, the relation between k1, k2 and k equivalent is given by 1 by k equivalent is equals to 1 by k1 plus 1 by k2. Okay. One more thing. Whenever springs are added in series, note one thing. If I pull this spring outward, okay, or if the spring is stressed, if both the springs are stressed, the force transmitted outward, suppose if I pull this with F, so this entire F would be transmitted out here. So even this spring would be experiencing a force of F. That means the elongating force in both the springs would be equal. Okay, if the elongating force out here is F, the elongating force out here would also be F. However, the length of elongation or compression would be different for both. Okay, now for parallel addition. See, in parallel addition, if two springs of spring constant K1 and K2 are added in parallel, the K equivalent would be given by K1 plus K2, or K equivalent is equals to K1 plus K2. Now note out here, in parallel addition, the elongation of both the springs are same. However, the elongating force or the compressing force of spring 1 is very different from elongating or compressing force of spring 2. So in series addition, what will happen? The elongating force of both the spring would be same. Elongating or compressing force of both the spring would be same. However, the length of elongation or compression of both the springs will be different. In parallel addition, what happens? The length of elongation or compression in both the springs are same. However, the force of elongation or compression, that means elongating force Kx, okay, is different for both the springs, and K equivalent is equals to K1 by K2. This brings us to another interesting question. Tell me, okay, this is spring K1, this is a mass kept out here, and this is spring K2. Are this spring in series or parallel? Is this body in series or parallel? This is in parallel. Why? Because if I shift this mass towards right, the length of elongation of this spring is exactly as same as length as compression of this spring, isn't it? So length of or force of elongation is not same. Okay, the length of elongation of this spring is exactly equals to length of compression of this spring. So this spring or this system is nothing but springs in parallel, or this is nothing but parallel addition. Although the direction of spring force are different, but the length of elongation of compression out here. So this is a parallel connection. Just imagine, just rotate this entire thing out here and add it like this. It will be similar to same this diagram. However, this diagram, in the first diagram, it is nothing but this one. Okay, the block is kept somewhere around here and it is applied some force A. Understood? Now what we'll study is cutting off spring. The third portion would be cutting off spring. Now remember, in cutting off spring, if a spring or spring constant K and natural length L0, L0 is the natural length of the spring, is cut into two pieces, one of length L1 and other one of length L2, or three pieces or four pieces or five pieces. Okay, what is the relation between L1, L2? L1 plus L2 is equals to, or L1 plus L2 is equals to L0, because if this spring is cut, it will be the addition of all the length would be this length, no? The question would be asking what is the spring constant of first spring and what is the spring constant of second spring. Okay, the simple relation between all the spring constant is equals to K into initial length of the initial free length of the spring, or KL0, is equals to K1, or spring constant of new spring, into L1, which is equals to K2 into L2. If the spring is cut into three pieces, K3, L3, as long as L1 plus L2 plus L3 is equals to L0, okay, the relation between K1 and K2 would be given by this relation, where K into L0, K into natural free length of the spring is equals to K1 into first free length of the spring into K2 into is equals to K2 into second free length of the spring. Okay, so this is the few basics concept of spring out here that I've given you. The third part is work done by a spring. So work done by a spring is nothing but, so if a spring of natural length L0, okay, is stressed by force F and the elongated length becomes L0 plus X, the work done by spring would be given as minus half K into X square, where K is the spring constant and X is the amount of elongation or compression. Okay, and spring force is a conservative force, so the work done would be stored as potential energy. Okay,
Even this question is straightforward. There is a system, okay, which consists of two springs. K1 and K2. K1 and K2. K1 and K2 are the spring constant. Okay. Find the minimum work performed in order to stretch the system by delta L. Okay. So what is the minimum work done by a force to stretch the system by delta L? So what is the equivalent of this spring K1 and K2? Whenever springs are connected in series, we apply the laws of parallel. See, there are series connection and parallel connection. In class 10, we have learned series connection of resistance, parallel connection of resistance. Okay, so during electrical, okay, if resistors were connected in series, what is to do? R1 plus R2. And if resistors were connected in parallel, what is to do? 1 by R1 is equals to 1 by R equivalent is equals to 1 by R1 plus 1 by R2. You do the exact opposite for springs. Okay, if they are connected in spring or if they are connected in series, 1 by K equivalent is equals to 1 by K1 plus 1 by K2, and if they are connected in parallel, K equivalent is equals to K1 plus K2. Okay, so out here equivalent spring would be nothing but 1 by K equivalent, or K equivalent is K1 K2 by K1 plus K2. You just take LCM, K2 goes out here, K1 goes out here, K1 plus K2 divided by K1 K2. So 1 by K equivalent is equals to this entire value. Now flip it, because you need to find out K equivalent. So now you got a spring that has a K equivalent, and I need to stretch this by delta L, where K equivalent is equals to K1 K2 by K1 plus K2. Work done by spring is always minus half kx square. Okay, so work done by external force would be plus half kx square. Okay. Work done is equals to half, what is k? K is nothing but K equivalent, or K1 K2 divided by K1 plus K2 into what is x? X is nothing but delta L, that is given in the question. Delta L is nothing but x. So work done by external force is nothing but plus half K1 K2. See, this is nothing but work done by spring force is nothing but minus half Kx square. Work done by external force in this situation is nothing but plus half Kx square. Okay, work done by external force. Why and how did I arrange this one? Just assume a particle out here. No, initial velocity before stretching is equals to 0. Final velocity after stretching is equals to 0. Apply work energy theorem on the particle. Final kinetic energy minus initial kinetic energy is equals to 0, which is equals to total work done by all the forces. And on this imaginary particle, what are the two forces doing work? First one is the spring, second one is the external force. So spring force plus external force is equals to 0, or work done by spring force plus work done by external force is equals to 0. So if you know that work done by spring force is equals to minus half kx square, work done by external force would obviously be plus half kx square, okay, which is this value. Asha, why is work done by spring force negative? Work done by spring force is negative because spring force is always acting in the opposite direction of stretching. That means if I stretch the spring like this, the spring force would be acting in the opposite direction. If I compress the spring and the particle is going in this direction, the spring force would be acting outward. So spring force tends to act in the opposite direction of elongation or compression, okay, or opposite to the direction of motion. So look at this question. This question says that this is Earth, okay, and out here y is equals to 0. That means my grid reference or the coordinate reference is equals to 0 out here at the surface of the Earth. As I go up, the value of y increases. So a particle is out here at the surface of the Earth, okay, and there are two forces acting on it. The first force is the gravity force due to the Earth's gravity, and the second force is the external force that has a value 2ay minus acha 2ay mg 2ay mg minus 2 mg minus 2 mg. Okay, this value, I'm talking about this value, the external force 2ay mg minus mg. If you expand this value, if we expand this entire value, we'll get this value of external force. Okay, now see, if you carefully see this force at y is equals to 0, what is the value of this entire thing? At y is equals to 0, the value of this entire thing is nothing but minus 2 mg, and minus of 2 vector means what? The vector is pointing in upward direction with magnitude 2 mg. So initially at y is equals to 0, the forces would be something like 2 mg upward and mg downward, mg due to gravity downward and 2 mg upward. Okay, so the net force would be mg upward. Okay, so the body would start moving upward. So as the body start moving upward, what will happen? This value of y would increase. So when the value of y increases, what happens? The net force in upward direction slowly decreases. Okay, and it will come up to a time till the net force becomes 0, then everything becomes 0, till the body reaches the highest point. Okay, at highest point, what is the condition? At highest point, the condition is velocity is equals to 0. Okay, suppose any projectile motion or any motion, okay, what is the maximum height? For maximum height, the velocity is equals to 0 at maximum height. That is the necessary condition. Okay, for any mechanics problem, whenever they are asking you the maximum height, velocity is equals to 0 at maximum height. Okay, so at maximum height, velocity would be equals to 0. Let this height be h. Okay, the body reached up to height h, okay, with the help of these two forces. Fair and fine. Now the question is saying find the work performed by this force. So find the work performed by this force and the increment of body's potential energy in the gravitational field over first half of the ascent. That means while ascending, okay, while ascending or while going up, okay, this force will do some work. Find the work done by this force till h is equals to 2. That means till half the path or half the path of ascent. Find the work performed by this force and the increment of body's potential energy in the gravitational field of earth over half the ascent. That means up till h by 2 or up till half the maximum height. Okay, find the work done by this force up till half the maximum height. Fair and fine. So let's see. Okay, net force on the body. Net force is equals to 2ay mg minus 2 mg, okay, plus mg. 2ay mg minus 2 mg is nothing but this force, and plus mg is nothing but gravitational force. So net force is equals to how much? Minus 2 mg plus 2 mg would become 2ay mg plus, sorry, not plus, minus mg, minus mg. Okay, or it would become mg 2ay minus 1, 2ay minus 1. This is the net force in downward direction. Okay, if you look at the net force in downward direction, no, at y is equals to 0. Okay, I don't know the value of a, so at y is equals to 0, what will happen? It would become minus mg. Minus mg means it is going in upward direction. Okay, or the net force is in upward direction. See, if you put y is equals to 0, the entire total force would be minus mg. Okay, what I need to find out right now is the maximum height. Okay, so initially started with initial velocity, it started with was equals to 0, u is equals to 0. Okay, u is equals to 0. So and the force, it accelerated it, okay, for whatever it has done, and it reached up till a maximum height. At maximum height, what is the necessary condition? The necessary condition at maximum height is v is equals to 0. Okay. Okay. So the net force acting on the body is mg2ay minus 1. What is the net acceleration? Net acceleration is nothing but net force divided by mass. Why? Because force is equals to mass into acceleration. 2ay minus 1 divided by mass. Mass and mass gets cancelled. G into 2ay minus 1. See, the net acceleration is this value. So can I say acceleration of the particle is equals to g2ay minus 1, or acceleration can be written as, see, out here, acceleration is equals to g2ay minus 1. Acceleration can be written as v dv by dy. That means this particle is moving in y direction, no? Okay, and the acceleration is dependent upon y, so acceleration is given as a function of y. Okay, so v dv by dy is nothing but the acceleration is equals to g2ay minus 1. So if I integrate this one, v dv, or let's integrate out here, v dv is equals to g into 2ay minus 1 into dy. Okay, or v square by 2, is equals to g into 2ay square by 2, 2ay square by 2, okay, minus y. Okay, now we need to put down the limits of this integral. Okay, or you can put down plus constant and put down the boundary condition, but to save some time I'm doing direct integration out here. Okay, I just integrate this entire term. V dv is nothing but v square by 2, g is constant which is taken outside, integration of tay dy is nothing but 2ay square by 2, and minus y dy is nothing but minus y. Okay, so out here, see, I can simply little bit simplify this one. 2 and 2 would get cancelled, or ay square, it would be ay square. Okay, so what are the lower limits and upper limits of this integral? See, for y, it started at y is equals to 0, y is equals to 0. Okay, y is equals to 0, y is equals to 0. Okay, what was the velocity at y is equals to 0? The velocity at y is equals to 0 was 0, and the maximum value of y is nothing but h. So it ended at y is equals to h, y is equals to h. And what was the velocity of the particle at y is equals to h? It was simply 0. Okay, so if I do this one, 0 square by 2 minus 0 square by 2 is nothing but 0, is equals to g into a, h square, minus 0 square is 0, minus h, minus 0. So it is nothing but this value. Okay, or if I substitute this value, okay, if I solve this equation, I get the value of h. See, g can be equated to 0. Okay, or a square minus h is equals to 0. If I send the h to the right hand side, it would become a square is equals to h. This h would cut by 1 and h, or h is equals to 1 by a. So the maximum height of the ball that has been reached is equals to 1 by a. Fair and fine. I find out the maximum height till which the ball can reach. Okay, the necessary condition for maximum height is v is equals to 0. Okay, find the work performed by this force in the increment of, and the increment of body's potential energy in the gravitational field. Achha, what is the work performed by this force for half of this ascent? Achha, what is half of this ascent? What is h by 2? Half of the ascent is nothing but h by 2. Okay, h is nothing but 1 by a, so 1 by 2a. H by 2 is nothing but 1 by 2a. Okay, now work done by force. work is nothing but work done by force is nothing but force into displacement, or what is the value of force? 2ay mg minus 2 mg. So I have to find out the work done by this force. Okay, find the work performed by this force. Now this force is variable. Okay, as it goes up the force changes, this force changes, so you have to integrate this one dy. Okay, and one more thing, the value of this, the work done by this, is nothing but negative. Why? Not negative, it's a positive. This is positive because force is acting in upward direction. Let me check. Minus 2 mg, force is acting in upward direction and displacement is also acting in upward direction. Okay, this is means we don't have to change any sign out here. Okay, out here. Okay, work is performed from y is equals to 0 to y is equals to 1 by 2a. Okay, now let's integrate this one, or work done by force. Work done by force is nothing but 2a mg into y square by 2 from y is equals to 0 to 1 by 2a minus 2 mg into y from y is equals to 0 to 1 by 2a, or work done by force is equals to 2a mg. Okay, what is y square by 2? 1 by 2a whole square. 1 by 2a whole square minus 0 square divided by 2 minus 2 mg. Okay, into 1 by 2a minus 0. Okay, so out here this 2 and this 2 get cancelled, and out here acha, let's see this. So work done by force is equals to a mg into 1 by 2a whole square is nothing but 1 by 4a square. 1 by 4a square. Okay, minus 2 mg into 1 by 2a into 1 by 2a. Okay, out here 2 and 2 would get cancelled. Out here a and a square would get cancelled. So it is mg by 4a minus mg by a. What is mg by 4a minus mg by a? Mg by a. Okay. Okay. So work done would be how much? Mg by 4a minus mg by a. If I take mg by a common, is nothing but 1 by 4 minus 1, or is equals to minus 3 by 4 mg by a. Minus 3 by 4 mg by a. Okay. Now a confusion that I have out here is this should be minus or plus. Okay. So let's check out here. Okay. The force that is given is in downward direction. The displacement that I'm calculating is in upward direction. dy is calculated or integrated in upward direction, no? So the angle between force and displacement is 180 degree. Okay, and cos of 180 is nothing but minus 1. So out here it would be minus. So the entire thing would be multiplied by minus. Okay, so instead of putting minus at every point, I'm just putting minus at work done. Okay, and later on we'll uh, exchange the minus with, okay, or minus of work done by force, or minus of work done by force is equals to minus 3 by 4 mg by a, or work done by force is equals to mg by a. Okay, and the second part of the question is find the increment of body's potential energy in the gravitational field of earth over the first half of ascent. Okay, so as the body, or as the body rises, okay, the increment in body's potential energy, due to gravity forces of earth, the potential energy of the body would increase. Find the increase in potential energy. So increase in potential energy is nothing but negative of work done by gravity, or minus of or mg into h by 2. H by 2, what is h by 2? H by 2 is nothing but 1 by 2a, or mg into 1 by 2a, or is equals to mg by 2a. This is the increase in potential energy. Okay,